A weightless piston divides a thermally insulated cylinder into two parts. One part contains 1 mole and other part is evacuated. Then the piston is released and gas fills the whole volume of the cylinder. Then the piston is slowly displaced back to its initial position. So first part, when the piston is suddenly released, is a case of free expansion. And when piston is slowly displaced back, that is a reversible process. Find the increment of the internal energy and the entropy of the gas resulting from these two processes. So let's draw PV graph for the process. So we have already seen in the previous problem also that free expansion is isothermal process. And it's given that volume changes 2 times because the piston divides the cylinder in 2 equal parts. So in the isothermal process, volume increases from V to 2V. So this part is the free expansion part. After that, piston is slowly displaced back to the initial position. So final volume is same as initial volume. And because the cylinder is thermally insulated, the process got to be adiabatic. So from here to here, the process is adiabatic. So this is the whole process. We need to find the increment in internal energy and entropy change. So let's do entropy change first. So in free expansion, we have already seen in the previous problem that change in entropy is given by N naught R ln ratio of volume. So volume change is given as 2. So and in the adiabatic process, since it is reversible, delta S is 0. So total change in entropy is delta S1 plus delta S2, which will be N naught R ln 2. Delta U. So again, for the free expansion part, delta U is 0 and everything is 0 in free expansion except entropy change. So delta Q is also 0, delta W is also 0, and therefore delta U is also 0 because it's an isothermal process. And in the adiabatic reversible compression, we know delta U is N naught CV Tf minus T naught. And because the process is adiabatic and the ratio of volume change is given, we can find the final temperature. So by this equation. So we find the final temperature, put it here, and T naught is given to us in the problem. So we get the change in internal energy from this to this. So in a simple adiabatic process. So total change in internal energy is 0 plus this, which becomes this, our answer.